what we really wanted to achieve here is like, well, why make this really fast car that's crazy fast and everything? We got to show that an electric car is the best car.
The future was supposed to be electric. Tesla's dominance seemed inevitable.
We have a very good relationship with Toyota, and they're a significant shareholder in Tesla.
Elon Musk's vision of an all-electric world appeared unstoppable. But in late 2024, something changed after a secret meeting at Toyota's headquarters in Japan. Elon was visibly shaken. What he saw that day would challenge everything we thought we knew about the future of transportation. Let's dive into the rise of an empire. Elon Musk thought he had won. Tesla's stock was soaring, legacy automakers were scrambling to catch up, and the future seemed purely electric. But while the world was busy watching the EV revolution, Toyota, the world's largest automaker, was working on something that would change everything. This isn't just another hybrid system or minor improvement. Elon himself says that this engine promises to destroy the entire EV industry. But before we get to that, we must first understand how we got here. The story begins nearly a century ago in a small textile company in Japan, where a family's dedication to innovation would lay the foundation for one of the greatest technological leaps in automotive history. Sakichi Toyota was an ingenious inventor who revolutionized the textile industry with his creation of the automatic loom. This invention not only automated the weaving process but also introduced the concept of *judoka*, or automation with a human touch, allowing machines to halt automatically when a problem occurs. This principle became a cornerstone of Toyota's manufacturing philosophy. Building upon his father's legacy, Kichiro Toyota ventured into the automotive industry. Observing the inefficiencies in American mass production systems, Kichiro envisioned a more streamlined approach. He developed the just-in-time JIT production method, emphasizing the production of only what was needed, when it was needed, and in the exact amount required. This strategy minimized waste and optimized efficiency, laying the foundation for what would become the Toyota Production System, TPS. The TPS is built upon two fundamental pillars, JIT and *judoka*. While JIT focuses on synchronizing production processes to ensure a continuous flow and reduce waste, *judoka* emphasizes quality control by empowering workers and machines to detect and address issues immediately. This dual approach not only enhanced productivity but also ensured that quality was ingrained in every step of the manufacturing process. Toyota's commitment to continuous improvement, known as *Kaizen*, further distinguished it from its competitors. This philosophy encouraged every employee, from assembly line workers to executives, to actively seek out and implement improvements in their daily tasks. By fostering a culture where suggestions for enhancement were valued and acted upon, Toyota cultivated an environment of perpetual innovation. The company's adeptness at reading market trends became evident during the 1973 oil crisis. As fuel prices soared and consumers sought more fuel-efficient vehicles, Toyota was ready with models like the Corolla. These cars offered exceptional fuel economy at a time when many American manufacturers were grappling with a declining demand for their less efficient, larger vehicles. Toyota's foresight and agility during this period solidified its reputation as a responsive and forward-thinking automaker. In the early 2000s, Toyota once again demonstrated its innovative prowess with the introduction of the Prius, the world's first mass-produced hybrid vehicle. By combining a gasoline engine with an electric motor, the Prius delivered impressive fuel efficiency and reduced emissions, appealing to environmentally conscious consumers. This move not only set a new standard in automotive technology, but also underscored Toyota's role as a pioneer in sustainable mobility solutions. Through its unwavering dedication to efficiency, quality, and innovation, Toyota transformed from a small loom manufacturer into a global automotive powerhouse. The principles established by Sakichi and Kichiro Toyota continue to guide the company, ensuring that it remains at the forefront of the automotive industry. But there is more to this story than meets the eye, and this brings us to the internal combustion engine. The internal combustion engine, ICE, has been a cornerstone of technological advancement for over a century, driving the vehicles that have shaped modern society. Its evolution is marked by continuous improvements in efficiency, power, and reliability. The journey of the internal combustion engine began in the late 18th and early 19th centuries. In 1791, John Barber developed a gas turbine, and by 1794, Thomas Mead had patented a gas engine. That same year, Robert Street built an engine that was the first to use liquid fuel. These early endeavors laid the groundwork for future developments. In 1807, French engineers Nice Niepce and Claude Niepce ran a prototype internal combustion engine, the *4*, which powered a boat on the Saône River in France. This was followed by Swiss engineer François-Isaac de Rivaz's hydrogen-based internal combustion engine, which he fitted to a primitive vehicle, marking one of the earliest instances of an internal combustion-powered automobile. A significant milestone was achieved in 1876 when Nikolaus Otto, working with Gottlieb Daimler and Wilhelm Maybach, developed the compressed charge four-stroke cycle engine. This design, known as the Otto cycle, became the foundation for most modern internal combustion engines. The four-stroke engine's process, involving intake, compression, power, and exhaust strokes, allowed for more efficient fuel combustion and power generation. Toyota's journey with the internal combustion engine is marked by a commitment to innovation and quality. The company's engines have garnered a reputation for exceptional durability and performance. A prime example is the 2JZ engine, introduced in the early 1990s. This 3.0L inline-six engine, found in models like the Toyota Supra, became legendary among automotive enthusiasts. Its robust construction allowed it to handle significant power increases, making it a favorite for tuners and racers. When speaking of technological advancements, Toyota has been at the forefront. The introduction of variable valve timing with intelligence, VVTi, in 1995 marked a significant leap in engine efficiency and performance. This system optimizes the timing of the intake and exhaust valves, enhancing power output while improving fuel efficiency. Building upon this, Toyota developed dual VVTi, adjusting timing on both the intake and exhaust camshafts, further refining engine performance. In 2007, Toyota introduced the Valvomatic system, offering continuous adjustment to valve lift and timing. This innovation improved fuel efficiency by controlling the fuel air intake using valve control rather than a conventional throttle plate. The result was a more responsive engine with reduced emissions. As environmental concerns grew, the automotive industry faced increasing pressure to reduce emissions and improve fuel efficiency. Toyota responded by developing lean burn engines, which operate with a higher air-to-fuel ratio than conventional engines. In 1984, Toyota became the first automaker in the world to begin mass-producing lean burn engines. These new engines offered improved fuel efficiency and reduced emissions, aligning with global efforts to combat environmental degradation. In 1997, Toyota revolutionized the automotive world with the introduction of the Prius, the first mass-produced hybrid vehicle. The hybrid synergy drive system combined a gasoline engine with an electric motor, allowing the vehicle to operate on either power source or a combination of both. This innovation resulted in exceptional fuel efficiency and lower emissions, setting a new standard for environmentally conscious driving. Toyota's dedication to refining the internal combustion engine has not waned. The company has developed new combustion engines that are more compact and efficient, capable of running on various fuels, including gasoline, synthetic fuels, biodiesel, and hydrogen. These engines are designed to meet strict environmental standards and can be used in a variety of vehicle types, including hybrids and biofuel cars. Enter Elon Musk in 2008. As Toyota was refining its hybrid technology, a new player emerged on the automotive scene, Tesla Motors, under the leadership of none other than Elon Musk. His vision was clear. Electric vehicles were the future. Tesla's journey, marked by innovation and ambition, would soon challenge traditional automakers and reshape the industry's landscape. Tesla Motors was actually founded in 2003 by engineers Martin Eberhard and Mark Tarpenning, with the goal of producing high-performance electric sports cars. In 2004, Elon led Tesla's initial funding round, investing $6.5 million and becoming the company's chairman. Elon took an active role in product design and strategy, steering the company toward ambitious goals. In 2008, Tesla introduced its first vehicle, The Roadster, a sports car that could accelerate from 0 to 60 miles per hour in under 4 seconds and offered a range of over 200 miles on a single charge. The Roadster shattered preconceived notions about electric cars, demonstrating that EVs could be both high-performing and desirable. Building on the Roadster's success, Tesla launched the Model S sedan in 2012. The Model S received widespread acclaim for its performance, safety features, and sleek design. It was the first electric car to top the monthly sales ranking in any country, signaling a shift in consumer perceptions and market dynamics. Tesla continued to expand its lineup with the introduction of the Model X SUV in 2015 and the more affordable Model 3 sedan in 2017. The Model 3, in particular, was crucial in bringing electric vehicles to a wider audience, becoming the best-selling electric car globally. In 2014, Tesla announced its autopilot system, a suite of advanced driver assistance features. Musk's vision extended beyond partial automation. He frequently spoke about achieving full self-driving capabilities. Despite ambitious timelines, fully autonomous driving remained a complex challenge, with Tesla facing both technical hurdles and regulatory scrutiny. Tesla's rapid ascent was not without obstacles. The company faced production challenges, legal disputes, and financial pressures. Elon's leadership style and public statements occasionally attracted criticism and regulatory attention. Of course, Tesla's influence extended beyond its vehicles. The company's focus on renewable energy solutions, such as solar panels and energy storage products, aligned with global sustainability trends. Tesla's success also spurred traditional automakers to accelerate their own electric vehicle programs, intensifying competition in the EV market. As the story unfolds, Elon's influence remains a central theme in the evolving story of electric vehicles. However, the battery dilemma presents a significant challenge. As the automotive industry accelerates toward an electric future, the enthusiasm for EVs is tempered by significant challenges associated with battery production. While EVs promise reduced tailpipe emissions, the environmental and logistical complexities of battery manufacturing present a multifaceted dilemma. The production of lithium-ion batteries, the cornerstone of most EVs, involves the extraction of critical minerals such as lithium, cobalt, and nickel. Mining these materials is resource-intensive and often environmentally detrimental. For instance, lithium extraction in South America's Lithium Triangle, consisting of Chile, Bolivia, and Argentina, has led to significant water depletion in arid regions, adversely affecting local ecosystems and communities. Similarly, cobalt mining in the Democratic Republic of Congo has been linked to soil and water contamination, as well as human rights concerns. Beyond mining, the battery manufacturing process is energy-intensive, contributing to substantial greenhouse gas emissions. Studies indicate that producing a single EV battery can emit up to 4 tons of CO2, requiring years of vehicle operation to offset this initial carbon footprint. Additionally, the global supply chain for battery materials often involves extensive transportation, further increasing emissions. The finite availability of essential minerals also poses a significant challenge. As EV adoption rises, the demand for lithium, cobalt, and nickel is expected to outpace supply, potentially leading to resource shortages and increased prices. This scarcity is only worsened by geopolitical factors, as a substantial portion of these minerals is concentrated in politically unstable regions. For example, over 60% of the world's cobalt supply originates from the Democratic Republic of Congo, a nation plagued by political instability and ethical mining concerns. Addressing the environmental impact of EV batteries extends beyond production to include end-of-life management. Currently, only about 5% of lithium-ion batteries are recycled, primarily due to technological and economic barriers. Improper disposal can lead to soil and water contamination, while efficient recycling could mitigate environmental harm and alleviate resource scarcity by recovering valuable materials. Companies like Nissan and Volkswagen are investing in battery recycling initiatives, but widespread implementation remains limited. The transition to EVs also requires substantial investments in charging infrastructure and poses challenges for existing power grids. In many regions, the electrical grid may struggle to accommodate the increased demand from widespread EV adoption. Moreover, if the electricity used to charge EVs is generated from fossil fuels, the environmental benefits of reduced tailpipe emissions could be negated. Therefore, the effectiveness of EVs in reducing overall emissions is closely tied to the decarbonization of the energy sector. Recognizing these challenges, Toyota has adopted a more measured approach to electrification. The company has emphasized hybrid technology and is investing in alternative solutions such as hydrogen fuel cells. Their strategy reflects a belief that a diversified approach, including hybrids and hydrogen-powered vehicles, may be more practical and environmentally responsible in the short to medium term. This approach aims to balance consumer needs, environmental impact, and resource constraints. As the automotive industry grapples with these battery-related challenges, Toyota's engineers have been exploring innovative solutions that go beyond traditional paradigms. Their research has led to a groundbreaking development that could revolutionize the future of transportation, seamlessly integrating the benefits of internal combustion and electric power. Toyota has consistently demonstrated a commitment to innovation, balancing environmental responsibility with performance. Building upon its legacy of engineering excellence, Toyota is pioneering a new generation of internal combustion engines that promise to redefine industry standards and challenge the prevailing shift toward electric vehicles. In 2024, Toyota, in collaboration with Subaru and Mazda, announced the development of advanced internal combustion engines designed to integrate seamlessly with hybrid systems and operate on carbon-neutral fuels. These engines are engineered to be more compact than their predecessors, allowing for vehicle designs with lower hoods and improved aerodynamics, thereby enhancing fuel efficiency. Toyota's latest engine innovations focus on achieving higher thermal efficiency and versatility in fuel usage. The new engines are designed to run on various fuel types, including gasoline, synthetic e-fuels, biodiesel, and hydrogen. This flexibility not only reduces reliance on fossil fuels but also aligns with global efforts to minimize carbon emissions. A significant engineering breakthrough in these engines is the reduction of piston stroke, resulting in a more compact design. This modification posed considerable challenges but ultimately led to engines that are 10 to 20% smaller than existing models. The compact size allows for lower vehicle front ends, optimizing airflow and contributing to better fuel efficiency. To compensate for any torque loss due to the shorter stroke, the integration of electric motors provides instant power, ensuring that performance is not compromised. One of the most groundbreaking aspects of Toyota's new engine technology is its capability to utilize hydrogen as a fuel source. Unlike traditional fuel cell vehicles that convert hydrogen into electricity, Toyota's approach involves the direct combustion of hydrogen within the engine. This method leverages existing ICE technology while producing zero carbon emissions, with water vapor being the primary byproduct. The development of hydrogen combustion engines has been accelerated through Toyota's participation in motorsports. By deploying hydrogen-powered vehicles in racing scenarios, Toyota has been able to test and refine this technology under extreme conditions, gaining valuable insights that inform the development of consumer-ready models. Toyota's commitment to advancing ICE technology is further evidenced by its strategic partnerships. In 2024, Toyota, Subaru, and Mazda announced a joint initiative to develop new engines optimized for hybrid systems and compatible with carbon-neutral fuels. This collaboration aims to refine engine technologies through shared expertise and friendly competition, ensuring that the resulting powertrains meet the diverse needs of consumers while adhering to environmental standards. Looking ahead, Toyota plans to integrate these advanced engines into its vehicle lineup by 2027. The focus will be on hybrid applications, where the new ICE units will work in concert with electric motors to deliver enhanced performance and efficiency. Toyota's development of highly efficient, versatile internal combustion engines presents a compelling alternative to the all-electric paradigm that has dominated recent automotive discourse. By offering engines capable of utilizing carbon-neutral fuels and delivering exceptional performance, Toyota challenges the notion that EVs are the sole solution for sustainable transportation. This innovation not only provides consumers with more choices but also addresses some of the limitations associated with EVs, such as battery production impacts and charging infrastructure challenges. As Toyota prepares to introduce these engines to the market, the automotive industry may witness a renewed appreciation for the potential of internal combustion technology in achieving environmental objectives. But Elon Musk says there is more to the story than meets the eye. By 2023, the automotive industry faced a confluence of challenges that began to reveal the limitations of an all-electric future. Electric vehicle sales growth showed signs of slowing in major markets. Charging infrastructure struggled to keep pace with the rising number of EVs, and concerns about electrical grid capacity became more pronounced. Additionally, the fluctuating prices of raw materials essential for battery production and the environmental concerns associated with the disposal of aged EV batteries emerged as significant issues. Despite the initial surge in EV adoption, recent data indicated a deceleration in sales growth. Factors contributing to this slowdown included the high cost of EVs compared to traditional vehicles, limited driving range, and insufficient charging infrastructure in many regions. Consumers remained hesitant to fully embrace electric mobility, leading to lower-than-expected sales figures. For instance, in the United States, electric vehicles accounted for 18% of sales between January and October 2024, falling short of the 22% target set by regulatory mandates. The rapid increase in EV adoption highlighted significant shortcomings in charging infrastructure. Many areas lacked adequate charging stations, leading to long wait times and inconvenience for EV owners. Moreover, the existing electrical grids in several regions were ill-equipped to handle the additional load from widespread EV charging, raising concerns about grid stability and the potential for increased energy costs. The production of lithium-ion batteries, which power most EVs, relies heavily on raw materials such as lithium, cobalt, and nickel. The prices of these materials have been highly volatile, driven by supply chain disruptions and geopolitical tensions. On top of all this, the environmental impact of mining these materials, coupled with challenges in recycling used batteries, has raised questions about the overall sustainability of EVs. In response to these challenges, several traditional automakers began re-evaluating their aggressive all-electric strategies. Companies like Ford acknowledged that hybrid vehicles might play a more substantial role in the near term than previously anticipated. Amid these industry-wide challenges, Toyota's cautious approach to full electrification appeared increasingly prudent. The company has continued to invest heavily in hybrid technology and alternative solutions, such as hydrogen fuel cells, positioning itself to offer a balanced portfolio of vehicles that cater to varying consumer needs and regional infrastructure capabilities. This strategy not only mitigated the risks associated with an all-electric approach, but also aligned with global efforts to reduce carbon emissions through multiple pathways. As the automotive industry grapples with these complexities, Toyota is apparently preparing to unveil an innovation that would challenge prevailing assumptions about the future of transportation. This development promises to combine the strengths of internal combustion and electric power, offering a compelling alternative in the quest for sustainable mobility. In late 2024, something extraordinary happened behind closed doors. Elon Musk, the face of the electric vehicle revolution, made an unexpected visit to Toyota's headquarters in Japan. While such meetings between automotive executives aren't unusual, what made this visit different was its unprecedented level of secrecy and the events that followed. According to sources familiar with the matter, Toyota's CEO Koji Sato personally invited the tech mogul to review their latest technological developments. This unusual move sparked speculation throughout the industry. Why would Toyota share their closely guarded secrets with their theoretical competitor? The meeting is said to have lasted for over 6 hours. During this time, Elon was granted access to Toyota's most advanced research facility, where their next-generation engine technology was being developed. What happened in that facility remains largely confidential, but the impact was immediately apparent. Several engineers who worked closely with Elon reported a notable change in his demeanor upon his return. Namely, the billionaire appeared unusually contemplative. When pressed about the visit, Elon Musk simply stated, "Toyota's new engine will destroy the entire EV industry." Coming from a man who had dedicated his career to making electric vehicles mainstream, this statement sent shockwaves. So, what exactly did he see? While specific technical details remain under wraps, industry experts believe Toyota has achieved something previously thought impossible: an internal combustion engine that combines unprecedented efficiency with near-zero emissions. The system reportedly integrates advanced hydrogen combustion technology with a revolutionary hybrid system that requires minimal rare earth materials. The implications are staggering. Such an engine would offer the convenience and quick refueling of traditional vehicles while matching or exceeding the environmental benefits of electric vehicles. More importantly, it would sidestep many of the challenges facing mass EV adoption: grid capacity issues, charging infrastructure limitations, and the environmental impact of battery production. When asked about the technical specifics during a recent Tesla earnings call, Elon's response was uncharacteristically reserved. "I made my decision to respect Toyota's wishes and not reveal any technical details to the public. What I can say is that they've achieved something remarkable, something that's pushed me to think differently about the future of transportation. Tesla will need to work much harder to create something even better." This statement, coming from Elon, speaks volumes. It suggests that Toyota's innovation is a fundamental breakthrough that could reshape the entire automotive industry. Industry analysts even suggest that Toyota's new engine technology could begin appearing in production vehicles as early as 2026. The company has already filed numerous patents related to advanced combustion systems and hybrid powertrains, though the specific details remain heavily guarded. What's clear is that this development has forced a re-evaluation of the automotive industry's future. The assumption that battery electric vehicles would completely replace internal combustion engines is being challenged. Instead, we might be entering an era where multiple technologies coexist, each serving different needs and markets. What do you think the future will look like after hearing all of this? Let us know in the comments.